Hi everyone, this week we'll be talking about inferences on two samples. Inferences is another way of saying hypothesis testing. So these are all going to be hypothesis tests involving two samples and two parameters. And this is chapter 11. These are the chapter 11 slides. And in the slides are background notes on section 11.1 and some examples. And if you get a chance, they're good to look over. I'm going to go right to the lecture notes for section 11.1. And 11.1 is on hypothesis tests for two population proportions, P1 and P2, using two independent samples. Recall that there are some situations in which you may need to test a hypothesis about a population proportion. Here's one such example from section 10.2. In 2015, about 26% of households in Riverside County received some form of federal housing assistance. An economist suspects, however, that the population proportion of households in Riverside County who receive federal housing assistance has decreased since 2015. The economist obtains a random sample of 400 households and finds that 93 out of the 400 households receive federal housing assistance. Is there sufficient evidence to conclude that the population proportion of households in Riverside County who receive federal housing assistance has increased since 2015? In this example, there was one unknown and one known. The population proportion of households with federal housing assistance in 2015 was known. It was known to be 26%. But the current population proportion of houses with housing assistance was unknown. And for that problem, we call that P. By contrast, there are some situations in which there are 0 knowns and 2 unknowns. For example, consider the following. Magnotic is a pharmaceutical company that produces an allergy relief medication for pollen allergies called Videxia. Scientists at Magnotic would like to determine whether users of Videxia experience higher rates of insomnia than the general population of people with pollen allergies. In randomized, double-blind clinical trials of Videxia, a random sample of 1,200 people with pollen allergies were randomly divided into two groups. Subjects in Group 1, the treatment group, received 7 doses of Videxia over the course of a week, and subjects in Group 2, the control group, received 7 doses of a placebo over the course of a week. After completing the clinical trials, 56 out of the 700 subjects in Group 1 reported experiencing insomnia, while 36 out of the 500 subjects in Group 2 reported experiencing insomnia. Does the evidence suggest that users of Videxia experience higher rates of insomnia than the general population of people with pollen allergies? Use an alpha of 0.05 level of significance. There's a lot described in this study, and we'll come back to this study and work it out in more detail. But what is good to point out here is that in this study there are 0 knowns and 2 unknowns. The population proportion of Videxia users who experience insomnia is unknown, and also the population proportion of people with pollen allergies who do not take Videxia, who experience insomnia, is also unknown. So there are 2 unknown proportions. And here's a drawing just to illustrate what this problem was talking about. So you have a group of people with pollen allergies who take Videxia, and what we don't know is what proportion of them experience insomnia. And then there's another group of people who have pollen allergies who do not take Videxia, and we also don't know what proportion of them experience insomnia. Under certain conditions, namely these conditions, these inequalities, and later on we'll go into these in more detail, it is possible to test a hypothesis involving two unknown population proportions by using a probability distribution called the sampling distribution of the difference between two sample proportions. A sampling distribution of the difference between two sample proportions, given some sample size n, and given the unknown population proportions P1 and P2, has the following characteristics. This is the mean of that particular distribution, this is the standard deviation of that distribution, and that distribution is approximately normal if these two conditions are met. The hypothesis tests in section 11.1 by and large meet all of these conditions, and for this reason these hypothesis tests will be based on this particular kind of sampling distribution. There's another topic that is important to talk about before getting into more of these examples, and it's the idea of independent versus dependent samples. Two samples are independent if an individual selected for one sample does not determine which individual will be selected for the other sample. Here are a few examples. Both of these examples are taken from our textbook by Michael Sullivan. Joliet Junior College decided to implement a course redesign of its developmental mathematics program. Students either enrolled in a traditional lecture format course or a lab-based format in which lectures and homework are done using video and the course management system, MyMathLab. There were 1,200 students enrolled in the traditional lecture format and 300 enrolled in the lab-based format. Once the course ended, the researchers determined whether the students passed the course with an A, B, or C. The goal of the study was to determine whether the proportion of students who passed the lab-based format exceeded that of the lecture format. These are independent examples. The individuals who enrolled in the lab-based course were not determined by the individuals who enrolled in the traditional lecture course. So a person who decides to enter into the lab-based course, the fact that they enrolled in that course was not influenced at all by the fact that somebody else enrolled in the traditional lecture course. Let's look at another example. In May 2002, the Gallup organization asked 1,050 randomly selected adult Americans aged 18 or older, do you believe it is morally acceptable or morally wrong to conduct medical research using stem cells obtained from human embryos? And then they asked that same question of another 1,050 randomly selected adult Americans in May 2010. So here there are two samples, a sample from May 2002 and then another different sample from May 2010. And these are also independent samples. The individuals who were selected for the May 2010 sample were not determined by and also unrelated to the individuals who were selected for the May 2002 sample. So they had no connection to each other at all. They were just two completely different groups of people. And so they're independent samples. Two samples are dependent if an individual selected for one sample does somehow determine which individual will be selected for the other sample. Here are a few examples. Both of these examples are also taken from our textbook by Michael Sullivan. To test the belief that sons are taller than fathers, a student randomly selects 13 fathers who have adult male children. She records the height of both the father and son in inches and obtains the following data. Are sons taller than their fathers? The rest of this problem is not included, so when you see this problem, you'll see the actual data. But the point here is that these are dependent samples. The fathers who were selected determined who would be selected as the sons. In other words, since the study is comparing the heights of fathers and sons, for every father chosen, the study would have to choose that father's son. It wouldn't make sense to compare the heights of a father and some other father's son. So these samples are dependent, and they're also considered matched pairs because each father is paired up with his son. And we'll do one more example. A political scientist wants to know how a random sample of 18 to 25-year-olds feel about Democrats and Republicans in Congress. She obtains a random sample of 1,030 registered voters, 18 to 25 years of age, and asks, do you have a favorable or unfavorable opinion of the Democratic/Republican Party? Each individual was asked to disclose his or her opinion about each party. These are dependent samples, and the key here is it says that each individual was asked to disclose their opinion about each party. So each individual gave two responses. They responded to the question of whether they favor the Democratic Party, and then after that, they responded to the question of whether they favor the Republican Party. And because those two responses are coming from the same individual, they're paired up. They're linked to each other. The way that somebody would respond in one way to one question is going to affect how they respond to the other question, because their responses are linked and they're dependent on that individual's political views. So also these samples are considered matched pairs because the two responses from each individual are paired to each other. They're paired to the individual. In the next video, we'll take a look at the first example.